Welcome friends. Today let us discuss some problems about electric field intensity. So first we need to know what is meant by electric field intensity. For that, electric field intensity is defined as the force acting per unit charge. The force acting per unit charge F by Q is called as electric field intensity, which is expressed in either newtons per coulomb or volts per meter is also the unit for electric field intensity. But from Coulomb's law of electrostatics, we already know that the force acting between two charges is given by Q1, Q2 by 4 pi epsilon naught r square into AR bar. Suppose, assume that there is a charge Q1 and there is a charge Q2 separated by a distance r. Okay, this is the distance vector r bar, and the unit vector that is acting in this direction is a r bar. Okay, so the direction is towards Q2. That means force is acting on Q2 due to Q1. This force formula is given by this formula. Now electric field intensity E is expressed as force per unit charge. Suppose if you want to find the electric field intensity of Q1, that means with how much intensity this Q1 is showing the force on Q2, if we want to express, means that is given by E equal to, because already we know that F is equal to Q1 Q2 by 4 pi epsilon naught r square into AR bar divided by, because here we are considering that the force is acting on Q2, so the test charge that should be considered should be Q2. Now if this Q2 is cancelled, we can say that the electric field intensity at a particular point charge Q1 is given by E equal to Q1 by 4 pi epsilon naught r square into AR bar, where AR bar is the unit vector in the direction of the force. Okay. Now based on this formula of electric field intensity, let us solve one problem. The first problem I am taking the example is, I want to find the electric field intensity E in vector form at some point. Let us take 1, -2, 1. I want to find the electric field intensity at this particular point due to a point charge of 5 nanocoulombs, which is placed at a point 2, -2, 4. Let us take this example. We are saying that there is a charge of 5 nanocoulombs at this point. I want to find the electric field intensity at some other point 1, -2, 1 due to this charge, due to this 5 nanocoulombs charge. Okay. So where I want to find electric field intensity, this point. So let us take this point as P. Take this point as P and take the second point at which the charge is placed as Q. Okay. Now I want to find electric field intensity at this point P. So we need to find the distance vector first of all, because we know that the electric field intensity at a particular point charge is given by Q by 4 pi epsilon naught r square into AR bar. So we need to find the distance between these 2 points and also the unit vector. If we find these two, then we can directly substitute all the values in this formula and we can calculate the electric field intensity. Okay. So for that, to find the distance vector r bar, I should take P bar minus Q bar. Why I am taking P first means, because I want to find the electric field intensity at this point P. So that point should be kept first and the second point should be kept next. So if I subtract, P minus Q means 1 minus 2 is -1 minus AX. Next -2, minus of minus plus 2 means that will be cancelled and it will become 0, 0 AY. Next 1 minus 4 means -3 AZ bar. So totally your distance vector r bar is equal to -AX bar -3 AZ bar. Okay. So that let us see this subtraction again. The distance vector r bar is given by P bar minus Q bar. where P is this point and Q is this point. So 1 minus 2 is minus 1, minus 2, minus of minus 2 means minus 2 plus 2, they will be cancelled 0, and 1 minus 4 is minus 3. This is the distance vector. Let us find the magnitude for this. Mod r bar is equal to root over minus 1 square plus minus 3 square. Okay, that means root 1 plus 9, root 10. This is the magnitude of the distance vector. Now, how to find the unit vector here? How to find the unit vector AR bar? We have obtained the distance R. After that, our duty is to find the unit vector AR bar. That unit vector AR bar is given by R bar by mod R bar from our previous analysis. So, what is R bar here? R bar is minus AX bar minus 3AZ bar divided by, what is the magnitude of that? The magnitude of your vector is root 10. So your AR bar is minus 1 by root 10 into AX minus 3 by root 10 into AZ. This is the unit vector AR bar that is acting in the direction of the force. Now we have obtained the distance, we have obtained the unit vector. Now what is our aim? Our aim is to find the electric field intensity E at this particular point due to this charge. So what is the formula for E? E is given by Q by 4 pi epsilon naught R square into AR bar. This is the vector form of the electric field intensity. So what is the Q value? The charge Q is given as 5 nanocoulombs. That means 5 into 10 power minus 9 divided by 4 pi into, what is epsilon naught value? Epsilon naught is, we already know, 8.85 into 10 power minus 12, permittivity of free space. Next, what is the distance R value? The distance R value magnitude is root 10. So root 10 whole square, because it is R square, into what is AR bar? Already we have obtained the vector form for the unit vector AR bar. So multiply with that unit vector. That unit vector is given by minus 1 by root 10 into AX minus 3 by root 10 into AZ. Okay. Now if we multiply this entire value and if we calculate, then we will get the expression for E bar as of now, you simplify that in your calculators and your value will be some constant into AX bar and plus some constant into AZ bar. Okay. If you simplify this value and if you multiply with this unit vector, that value something will be coming, keep that here, into AX bar and another value you will get into AZ bar. Okay. This is the electric field intensity in vector form. What is the unit of electric field intensity? Is volts per meter. This is a simple problem to calculate the electric field intensity at a particular point charge. Okay. Electric field intensity at a point due to a particular point charge. Next, let us go for principle of superposition, which we have already dealt in Coulomb's law of electrostatics. The same principle is applicable for this electric field intensity E also, because E and F are proportional. Whichever the rules are applicable for F, that will be applicable for electric field intensity E also. So let us deal with that. Suppose take a point P. Okay, assume that there is a point P. Now I want to find the electric field intensity at this point P. We want to find the electric field intensity at this point P, which is in some space. That may be any coordinate system, either Cartesian or cylindrical or spherical. In one of the system, this point P is present. In space, there will be number of charges which are distributed randomly. There may be some charges from Q1, Q2, Q3. so on up to some qm charges will be present in space. Due to each charge, there will be some separate electric field intensity that will be acting on this point P. That means at this point P, you will be having electric field intensity due to Q1. At this point P, you will be also having electric field intensity due to Q2. At this point P, there will be some electric field intensity due to this charge Q3 also. And due to this Qn also, there will be some electric field intensity. That means some electric field intensity is being acted upon this point due to the charge Q1 as well as Q2, Q3, so on up to Qn. Every point charge will be showing some electric field intensity at this point P. Let us express the unit vectors. This is A1Q, A2Q, A3Q, ANQ. Now, according to the principle of superposition, the total electric field intensity that is acting at this point P is given by the vector sum of the individual electric field intensities. That means the total electric field intensity that is acting at this point P, take it as EP, is equal to, suppose the electric field intensity at this point P due to Q1 is E1. Similarly, the electric field intensity at this point P due to Q2 is E2. Like that, due to Q3, field intensity is E3, so on up to En. So, by principle of superposition, we can say that the total electric field intensity is equal to the sum of the individual field intensities which are acting due to these individual point charges. Now, based on this principle, let us solve some problems. So, this is also a very important model. Assume that 3 charges of 1 microcoulomb are placed at the corners of a square. 3 charges of 1 microcoulomb are placed at the corners of a square of 10 centimeters side. Okay, 3 point charges of 1 microcoulomb are placed at the corners of a square of 10 centimeters side. Now, I want to find the electric field intensity E. Find the electric field intensity E at the vacant corner. Electric field intensity E at the vacant corner. Now, the solution is very simple. Assume that the square is in XY plane. Assume that the square is in XY plane. That means, take this as x-axis, y, z. Assume that your square is present here. What is the side of the square? 10 centimeters. For a square, all the sides are of equal length. 10 centimeters means equal length means in meters if you express that will be 0.1. So the origin 0, 0, 0. Here what will be the point? Take this as some A. Here the point will be y-axis means x is 0, y is 0.1, z is 0. Here if you take this as D, x coordinate will be 0.1 and y and z will be 0. What is this point? This point will be here. There is no z coordinate, there is no height, so z coordinate is 0. But what about y? Y is 0.1 and x distance is also 0.1. So we have decided all the 3 points. Assume that 3 charges of 1 microcoulombs are placed at the corners of a square of side 10 centimeters. Side 10 centimeters we have already considered and we have fixed the point. This is the square that we are considering. Now three 1 microcoulomb charges. 1 microcoulomb charge. This is point C. This is here also 1 microcoulomb charge. So I am placing the three 1 microcoulomb charges at point B, point C, and point D. Okay. Now what is the vacant corner here? The vacant corner is point A. Now we need to find the electric field intensity at this point A, vacant corner, due to these charges that are present at B, C, and D. So for that we need to use the same formula again. What is the formula for E? Electric field intensity E is Q by 4 pi epsilon naught R square into AR bar. Again we will use the same formula. First let us find the electric field intensity at point A due to the charge at point B. What is the charge value? 1 microcoulombs. The charge value is 1 microcoulombs. Now charge is 1 microcoulomb, you can substitute that here. Epsilon naught is 8.85 into 10 power minus 12. And for distance vector and unit vectors, we need to solve it. Electric field intensity at point A due to B means the direction will be like this. Okay. So the distance vector R1 is given as A bar minus B bar, because at what point you want to find the intensity, first you should take that point only, next the other point. Okay, in which direction your arrow is going, that point you should take first. So for that, A bar minus B bar means 0 minus 0, 0 minus 0.1 minus 0.1 into AY, and again 0 minus 0 is 0. So this is the distance vector. Now what is the magnitude of this? Root over minus 0.1 square, that means 0.1. This is the magnitude mod R1. Now find the electric field intensity due to B. Electric field intensity due to B is, what is the charge value? Q value is 1 microcoulomb, 1 into 10 power minus 6 by 4 pi epsilon naught 8.85 into 10 power minus 12 into, what is R? R value here, the magnitude of the distance is 0.1. So 0.1 square into, what is the unit vector that we got here? The unit vector AR bar will be R1 bar by mod R1 bar, which is equal to minus 0.1 AY by 0.1, that means minus AY. As this point is on y axis and you are taking in opposite direction, your vector will be minus AY. So minus AY. Use your calculator and simplify this value. You will get some constant into AY bar. This is the electric field intensity at point A due to the charge at the point B. Similarly, you can find the electric field intensity at point A due to the charge at D also. Take that D means, let us mark this distance as some R3. First you find what is R3 distance vector. R3 means A bar minus D bar. A bar minus D bar means, you can see here 0 minus 0.1. That means minus 0.1 into AX bar plus remaining coordinates are zeros only. So you can leave it like that, 0. So minus 0.1 into AX bar is the distance vector. Distance vector. So mod R3 means, what is mod R3? Root over minus 0.1 whole square, that is 0.1. So your AR3 is given by R3 by mod R3, which is minus 0.1 AX by 0.1, that means minus AX. Now we can calculate the electric field intensity at this point A due to the charge at D. So ED is equal to, same formula you can use, Q by 4 pi epsilon naught R square into AR bar. Q means, what is the charge here? Again 1 microcoulomb, 1 into 10 power minus 6 by 4 pi epsilon naught 8.85 into 10 power minus 12 into r square means what is the distance 0.1 whole square into what is the unit vector? The unit vector here that we obtained is minus ax. So minus ax. So solve this, you will get some coefficient into ax bar. Okay, this is the electric field intensity at point A due to the charge at D. Now the last one is we need to find the electric field intensity at point A due to the charge at C also. And add all of the three, you will get the total electric field intensity at A. So the last step is to find the electric field intensity at A due to the charge at C. So for that, let us mark the distance from C to A, and your direction will be like this from C towards A, and the distance vector R2 bar. So for that R2 bar, how you can find R2 bar? Point, the intensity is going towards A, so A minus C. A bar minus C bar. So subtract them. 0 minus 0.1 means minus 0.1 into ax bar. Next 0 minus 0.1 again minus 0.1 into a by bar. That's all. Next z coordinate is 0. We can leave like that. Now what is mod R2 bar? Mod R2 bar is root over 0.1 square plus 0.1 square. So you solve this, you will get some value. Solve this using calculators. Now the unit vector acting in this direction is AR2 is R2 bar by mod R2 bar. Solve this. Okay, you can get the values, very simple. Now how to find the electric field intensity at point A due to the charge at C? That means EC is equal to same formula, Q by 4 pi epsilon naught R square into AR bar. Here what is the value of Q? Q is again 1 microcoulomb charge is placed here. 1 microcoulomb divided by 4 pi epsilon naught. Epsilon naught is 8.85 into 10 power minus 12. R value means simplify this R here, and AR value simplify this and substitute here. Now according to principle of superposition, what is the total electric field intensity at the vacant corner? That means EA, total electric field intensity at the vacant corner, is the vector sum of the individual electric field intensities produced due to the charges at D, C and B. That means EB plus EC plus ED. So find these values and find the vector sum. You can find the total electric field intensity at the point A, that means vacant corner. Near the vacant corner, you are finding the electric field intensity due to the charges at remaining three corners. So this is the procedure to find electric field intensity. Very important model for your SEM exams as well as some competitive exams. Next, we will do just small formula based sums. Okay, I hope all of you are clear with this. We know that the electric field intensity due to an infinite line charge is given by rho L by 2 pi epsilon naught R into AR bar. For this model, the electric field intensity due to an infinite line charge, they will give small sums only based on this formula. For example, find the electric field intensity due to a line charge of density rho L equal to 5 nanocoulombs per meter at a point 6, 8, 3. For these type of sums, directly we can find the unit vector AR bar is given by R bar by mod R bar. What is R bar? We can take a point on x-axis. Assume that the infinite line charge is placed on this z-axis. Your infinite line charge is placed on the z-axis with a line charge density of 5 nanocoulombs per meter. Okay, take the point here as 0, 0, z. They are asking you to find the electric field intensity at some point P 6, 8, 3. We already derived in the equations in our previous derivations that we can neglect the z coordinate. That means what is R bar? 6 minus 0 into AX bar plus 8 minus 0 into AY bar. From the derivation, I have explained why we are neglecting this z component. So for that, refer the derivations. Now your R bar distance vector is 6 AX bar plus 8 ay bar. How to find the magnitude for this? Root over 6 square plus 8 square. Simplify this and substitute here so that you will get the unit vector AR bar. Now directly we can substitute all the values. Electric field intensity due to this infinite line charge is rho L means substitute 5 nanocoulombs. That means 5 into 10 power minus 9. 2 pi epsilon naught is 8.85 into 10 power minus 12. And the distance R is, solve this value, you will get the distance. And AR bar is, you already know, substitute these values and keep that here. Then you can find the electric field intensity. Next formula is electric field intensity due to a charged circular ring. Rho L into Rz by 2 epsilon naught R square plus Z square whole power 3 by 2. They may give you the model as, take a charged circular ring in the xy plane. Take a charged circular ring in the xy plane and find the electric field intensity at a point P on the z axis, which is at a distance of some 10 centimeters from the origin, and the radius of this circular ring is some 5 centimeters. And the line charge density that is present in this circular ring is, they may give some value, some 8 nanocoulomb per meter like that. In the question they will give you. Now you know the value of Z, that is 10 centimeters, 0.1. You know the value of R, that is 0.5 meters or 5 centimeters. Substitute them here. You know epsilon naught values. After substituting, you can find the electric field intensity in vector form, which is acting in Z direction. Okay. And the third one is, we have also derived the electric field intensity due to infinite sheet charge. Infinite sheet charge, E bar is rho S by 2 epsilon naught into Az bar. That means we are taking an infinite sheet of charge in xy plane, and I want to find the electric field intensity at some point P on Z axis. Now they will give you simply what is the surface charge density of this sheet of charge. Let it be some 10 nanocoulombs per meter square. Simply if they give you the surface charge density of this particular sheet charge, you can directly substitute that in this formula and you can find the electric field intensity. Okay? So based on the derivation formulas, these are the direct application problems. Thank you.